Hello students, today we're going to talk about limits. The concept of limits or limiting process is essential to understanding of calculus. So what is a limit? To understand this concept, I want you to look at the three functions that I'm going to present, and I want you to pay attention to the behavior of the function around x is equal to 2 and at x is equal to 2. So the first function I want you to take a look at is the function f of x is equal to x squared minus 4 over x minus 2. This is the function right here. As you notice, when x is equal to 2, the function is undefined. When x approaches 2 from above, we notice that the function approaches a value of y equals to 4. When x approaches 2 from below, we notice that the function approaches a value of y equals to 4. The second function I want you to take a look at is g of x is equal to the absolute value of x minus 2 over x minus 2. This is the graph of the function, and one more time, when x is equal to 2, the function is undefined. As x approaches 2 from above, the function approaches a value of y equals to 1. As x approaches 2 from below, the function approaches a value of y equals to negative 1. The last function I want to take a look at is h of x is equal to 1 over x minus 2 all squared. Again, the function is undefined when x is equal to 2. As x approaches 2 from above, the function increases without a bound. As x approaches 2 from below, the function increases without a bound. Each of these functions is undefined at x is equal to 2. But if I make this statement and I don't make any other statement, then I am not giving a complete picture of how each of these functions behaves in the vicinity of x is equal to 2. So let's take a look again at the function f of x is equal to x squared minus 4 over x minus 2 and how it behaves around x is equal to 2. From this picture, you notice that the function is undefined when x is equal to 2. And as x approaches 2 from above or below, the function approaches a value of y equals to 4. We say that as the values of x approach 2 from either side of 2, the values of f of x approach 4. Mathematically, we say that the limit of the function f of x as x approaches 2 is 4. Symbolically, we're going to express it as the limit of f of x as x approaches 2 is equal to 4. So here is a definition of the limits, and if you want a detailed definition and more precise definition or mathematical definition of limits, please refer back to the book posted on D2L. I am going to share with you an intuitive definition of the limits because it makes more sense. We can think of the limit of a function at a number a as being the one real number L that the functional values approach as x values approach a. And here's the qualifier, provided such a real number L exists. And we write it as follows. We say the limit as x goes to a of f of x is equal to L. Again, we read it, the limit as x goes to a of f of x is L. And you have to remember here from the previous examples, we noticed that the limit is not relevant to the value of the function at the point. So keep that in mind. Today, we're going to talk about how we're going to evaluate a limit numerically, and I'm going to show you how to estimate the limit using a graph of a function. This is not a very practical approach, but it will get you somewhere. It's going to give you an answer. That answer might not be a precise answer, but it's going to help you determine whether the limit exists or it does not exist. So first, let's find the limit as x approaches 2 of x squared minus 4 over x minus 2. Since the value of the function when x is equal to 2 is irrelevant, we're going to choose some values that are very close to 2. Because we are mathematicians, we're going to choose some values that are above 2 and some values that are below 2. Namely, I chose 3 values that are below 2, slightly below 2, and 3 values that are above 2 because I'm a mathematician and I want to collect enough proof. Next, I'm going to find the value of the function at each of these points as follows. Notice here that all of these numbers, if I round them to a whole number, they're going to round to number 4. This is my hint that a limit might exist. I might do more work to find out what the limit is, which is going to provide me with more proof of the number that is going to be the limit of this function. I will round the original numbers, those numbers, to 2 decimal places and see if I have an agreement. Notice here that I have 2 numbers that agree, which is 4 and 4. So as a conclusion, I'm going to say the limit of x squared minus 4 over x minus 2 as x approaches 2 is equal to 4. If you graph the function, here's how you're going to find the limit of the function from the graph. If you approach x from above, you notice that the function approaches a value which is y equals to 4. If x approaches the value 2 from below, we notice that the function approaches a value which is y equals 4, and therefore the limit of the function is equal to 4. Now it's your turn. Find the limit as x approaches -3 of the function x squared minus 9 over x plus 3. The answer is -6. Here's another example. Find the limit as x approaches 2 of the function absolute value of x minus 2 over x minus 2. Again, I'm going to make a table of values. And since the value of the function at x is equal to 2 is irrelevant, as you notice here, it's undefined. So I'm going to choose values that are close to 2. And since I'm a mathematician, I want a little bit more than one value to come up with the right answer. So I will choose some numbers that are above 2, and I will choose some numbers that are below 2, and then compute the value of the function at each of these points. As you notice here, all of the values that are below 2 gave us -1. All of the values that are above 2 gave us 1. It doesn't appear that the function, the absolute value of x minus 2 over x minus 2 approaches any single number as x approaches 2. So I can conclude that no limit exists in this case. And to illustrate that from the graph, you notice that as x approaches 2 from above, the value of the function approaches a value of y equals 1. As x approaches 2 from below, the value of the function approaches a value of y equals -1. We can conclude that the limit does not exist because the limit from above is not equal to the limit from below. And this will lead us to a very important concept that we're going to talk about later on, which is the one-sided limit. Now it's your turn. Find the limit as x approaches 2 of 1 over x minus 2. If you concluded that the limit does not exist, then you were right. Let's take a look at evaluating limits using graphs. Sometimes it's easier to estimate the limit of a function from its graph. Let's say we're given the function g of x defined as it is equal to 3. If x is equal to -1, it's equal to x plus 1 all cubed plus 2 otherwise. We're going to find the limit as x approaches -1 of the function g of x. So we're going to graph it. If it exists, let's see if we can estimate what the limit is. As you notice here, g at -1 is equal to 3. And as the values of x approaches -1 from above, g of x values approach 2. As x values approach -1 from below, g of x values approach the value of 2, as you can see from the illustration here. Therefore, I can see that the limit of g of x is equal to 2. Note that we can determine this limit without even knowing the algebraic expression of the function. If I was given just a graph of a function, I would be able to estimate the limit of the function when x approaches a certain point without knowing the algebraic expression of the function. I hope this helped you understand the concept of limits and how we can determine the limits numerically and how we can estimate it using a graph or determine whether it exists or not numerically and using a graph. Next video, we will talk about the one-sided limits and the relationship between one-sided limits and two-sided limits. If you have any questions, please let me know. I will be available before class, and I'm also available after class to take your questions. I'll see you then.